Hello everybody, my name is Matthäus. Thanks for listening to me. Thanks to Steve for letting me use his laptop. Okay, so I want to present a possible application for private inheritance. So the question mark there is intentionally. So feel free to chat me up afterwards or send me a mail and let me know what you think about this. Okay, so private inheritance is quite a rare feature, so I figured we should do a short recap. Well, the syntax is more or less like the usual inheritance, but instead of using the word public, we use private. And the consequences are that the public and protected members of base are accessible as private members in derived. The private members of base are not accessible because they're private. That's never accessible for derived classes. And interesting also is that this inheritance relationship cannot be seen, or it can be seen, but it's not accessible from outside of derived. So you can't, outside of derived, use a static cast or expect the base and use a derived in that location. As a consequence, usually this is used to model has-a instead of is-a because it's not implicitly convertible. But there's disadvantage. Usually, if you want to do has-a, you use aggregation because, it's okay. I tried to explain it, maybe that's sufficient. You use aggregation because it produces less coupling than inheritance. So usually using private inheritance is not a good choice. There are some exceptions, however. Always the case if you don't want to model is-a, because in case of is-a, you would use public inheritance. But maybe you need to override a virtual function. Maybe you want to access a private member, or you want to use the empty base optimization. There are some more cases, but that's like some of them. Maybe you could argue that in these cases there's some flaw in your design. Maybe you need to do it like that, but that's the typical use cases. What I want to present is a use case which might be there, because the use case lives on kind of a language edge. We got a C API, so a DLL with a C interface. It's an API, so the idea is that other people can use your API. That's why we use C, so they can use it in their programming language of choice. Well, with most languages, it's possible to use C. And of course, this is a C++ meetup, so we want to implement this interface with C++. Maybe because you already got some code in C++, maybe it's your language of choice, maybe both. So how do we do that? Well, we could do the C-ish approach, but don't even bother to read that. I mean, it's C. We're on a C++ meetup. We don't want to do it this way. There's some more reasonable advantages and disadvantages. So the C, well, it's basically using free malloc and free. It's kind of straightforward. I mean, that's some of the first things you learn using malloc and free. It's easy to understand and the complexity is low. But of course, we have manual resource management, something we C++ programmers don't like. That includes raw owning pointers, something more that we don't like. It's very error prone, it's hard to get right. So while the complexity is low, it's hard with this low complexity to not commit errors, and it's very tedious. So how do we fix this? The idea is to introduce a class resourced widget, like this. Next step is we derive from widget, like this. Good thing is to default initialize the C struct. It has some pointers in it. Of course, we want them to be null pointers if there's nothing assigned. Okay, that's easy too. And now the fun part begins. So for every member that is there in this C struct, we add a member to our C++ struct, to the resource widget, which manages our resources. And yeah, for example, in this case, it's a string. And we add a setter. With this setter, we can assign a string. The string is assigned to the string member, and then the pointer to the string is assigned to the C struct, like this. Which in the end makes a class which pretty much feels like C++. And it's not error prone anymore, because of course the destructor cleans up our resources by destroying our resource managing members. This has some. Okay, you haven't seen the other. The C-ish implementation, sorry, but I mean, it's more or less straightforward. We create a resource widget as a unique pointer, so that if we return or there's an exception, something like that, we get automatic deletion. We get a foo from some place. Maybe we have error management. If the foo is empty, our resource widget gets, of course, freed. We can use the setter, so the string is assigned, the pointer is set correctly. And lastly, we give out the pointer to the struct, release it so that the unique pointer does not delete it, and we're done, right? Deleting should be similarly simple. Oh, sorry, I forgot the exception management. But there's one caveat here. We need the static cast, because it's a C struct. We can't add a virtual destructor. So if we would not add the static cast, we would delete with the static type, which would be widget, and then all our resource managing members would not get deleted. So we have memory leak. So this is really important here. Okay, what are the advantages here? In my opinion, this approach is way easier to use. We got automated resource management. We got the widget members initialized by default. We can't forget that. It's easier to implement create widget and free widget. And yeah, I already said that it feels like a C++ class. We don't have to work with const char pointers. We can use std strings. But there's two potentials for resource leaks. One is the static cast. I already told you about it. The other thing is that the widget members are still publicly available, because we derive publicly from widget, and it's a struct. So all its data members are public members of our resource widget. That's a part that does not feel so much like C++. So I was thinking, how could I change that? And of course, you can already guess that now. The solution is to use private inheritance, or a possible solution. Yeah, we pretty much got the same as before, but now we inherit privately. That doesn't change so much. There's now two more things we need to do, which is not so nice, possibly. As I told you before, the static cast cannot be done outside of the derived class, so we need a function to do the static cast. And the same is true for the deletion, right? We can't do the static cast there either, so we need a function which can do the delete. Create widget is not really that much different. We need this toWidget function which does the casting for us, and the same is true in free widget. So advantages: these members are not public anymore, which means that clients cannot, for example, accidentally pass a raw owning pointer, which would of course not get deleted because we trust in our resource managing members. And I believe it's easy to use right, hard to use wrong. It's kind of Kate Gregory's site here. But there are also some disadvantages. One of them is that you can still delete the resource widget and forget the static cast. But it's a bit easier to think of the static member function than to think of the static cast when you use it. Complexity increased. I already mentioned that. And it uses a private inheritance for a relationship. Well, it's kind of an is-a, because you can use the resource widget like a widget. But of course, it's not really what you're trying to model here. It's just a means of implementation. Yeah, what are the alternatives to this approach? You could leave out the introduction of the private inheritance and hope that all your clients will use that class correctly. You could use aggregation, as I said in the beginning, which is the better solution for HASA. But that's hard if you don't have state between the create and the free function, because then you can't really get from the pointer to the data member back to the pointer to the class, unless you do some tricky type system leaving stuff maybe adding offsets, reinterpret casting. Yeah, that's more or less this solution. Or you could use a handle approach. You could just hide the pointer, use it as a void pointer, hide it behind a type def, and instead of accessing the data, the member variables, you have a function which you pass the handle, and then it accesses the class. But of course, that creates a lot of functions in your API. That's maybe also not the way to go. So yeah, that's basically it. I think it's all a bit of questions of pro and cons and your concrete situation. How many usages you have for this class, how likely it is that it gets used wrong. So I'd be happy if you share your opinion. I'll put the slides in the C++ later, so you can write me, and you can even have a look at a not really complex, but there's an example on Coliroo if you're interested or if you want to play around with it. So thank you very much.